concepts. Our next topic is length of an arc. Measure of length of an arc. So in circular system we have seen angular measure or measure of an angle in radians is defined as ratio of length of arc to radius. So if theta be measure of an angle and s be the length of arc intercepted and r be the corresponding radii, so theta radians is s by r. If I make s as the subject in the formula, that is, if I rearrange the term, if I take r on the other side, so what I get is s is equal to r into theta. So this gives us an expression to find length of an arc. So what is length of an arc? Central angle of which is theta radians and r be the radius. The length of arc is product of radius and angle in radians, right? S is r into theta, that is product of radius and central angle measured in radians, right? Now we'll solve 2 or 3 problems to clear it, then we'll move to next topic. Now moving to next topic, that is area of sector. We know area of full circle is pi r square. Now here we have a sector, angular measure of which is theta radians. Now question is, what is this area, right? So using the concept of proportionality, we'll try to deduce what is the area of the sector corresponding to central angle theta radians. If you consider full circle angle, measure of it is 2 pi radians, and in that case area swept by the radius is pi r square. So 2 pi radians corresponds to pi r square. So 1 radians corresponds to pi r square by 2 pi. Pi gets cancelled, half r square. So area of sector of measure 1 radian is half r square. In this case we have sector of area theta radians. Sector of measure theta radians. So 1 radian corresponds to half r square. So area of sector corresponding to theta radians is half r square theta, right? So area of sector from now onwards we'll say is half r square theta. Remember, theta here is measured in radians. We had a formula for area of sector in junior classes also. There we have measured area of sector as theta by 360 into pi r square. But there angle was measured in degrees. Here our formula is half r square theta, and theta here is measured in radians, right? So from now onwards I'll say area of a sector is given by formula half r square theta, where theta is measured in radians. Okay. Now let's rearrange the terms and see if we can relate area of a sector and arc of a length of arc, corresponding length of arc. Area of sector is half r square theta. Let's rearrange it and write it as half r into r theta. Now what is this quantity r theta? R theta is length of the arc. R theta is length of arc. So area of sector now I can say is half r into s. That is half the product of radius and corresponding arc length, right? Half of product of radius and corresponding length of arc. Okay. Now again we'll move to board and we'll solve few problems to clear the concept. Let's solve few sums based on or problems based on length of an arc. Here I have written 2 questions. Let's solve these. First one. Question is, what will be distance travelled by tip of minute hand of a clock of length 11 centimeter in 45 minutes? So I'll draw a figure, supporting figure. Suppose there is minute hand of a clock. It rotates in clockwise sense. Question is, what is length or distance traveled by tip of minute hand of a clock which is 11 centimeter in length in 45 minutes? This figure is not up to scale. Angle I have marked is just indicative, it's not up to scale. So question is, what the distance traveled by minute hand of a clock of length 11 centimeter in 45 minutes. So that will be basically length of the arc intercepted by this angle. Which angle? The angle by which minute hand of a clock rotates in 45 minutes, right? So what we have to do is, we have to measure this distance traveled by tip of minute hand of a clock, which is nothing but length of arc of radius 11 centimeter. Of course, this angle is not known till time. So length of arc, we know, is measured by formula r into theta, where theta is measured in radians. Radius is length of the minute hand, that is 11 centimeter. Theta, the angle traced by minute hand in 45 minutes, is not known. Radius is known. Radius is 11. Now this angle. Question is, in how many minutes does the minute hand completes one rotation? Answer is 60. So minute hand completes one rotation in 60 minutes. So what angle does this minute hand of a clock traces? This direction. Angle by which minute hand rotates in 45 minutes would be what? 2 pi. 2 pi is full thing in 60 minutes. So in 45 minutes how much? 2 pi divided by 60 into 45. This many centimeters is the distance by which the tip of minute hand of clock has moved. I'll repeat this. Theta in radians we need. Full circle corresponds to 2 pi radians, and that is in 60 minutes. So 2 pi in 60 minutes. So per minute 2 pi by 60. In 45 minutes, by what angle does this minute hand moves? 2 pi by 60 into 45. Right? So if you cancel out this by 3, 40, 15, this is 3, this is 4, this is 2. So answer is 11 3s are 33 by 2. 33 by 2 is 16.5 pi centimeter. So tip of the minute hand of the clock moves by 16.5 pi centimeters in 40. So now moving to next question. Distance travelled by cycle, wheel of which is of radius 20 centimeter, by the time wheel completes 3 quarters. I have missed a word. By the time wheel completes 3 quarters. Right? So question is what? Distance travelled by cycle, wheel of which is of radius 20 centimeter, by the time wheel completes 3 quarters. So if this is the wheel, radius of which is 20 centimeter, and we have to find the distance by which this cycle would have moved by the time this has completed 3 quarters. Right? 3/4 of the rotation. So if you observe the figure, distance travelled by cycle wheel by the time this wheel completes 3 quarters is same as the length of this arc. Right? So distance travelled is same as length of arc. So length of arc once again is measured as r into theta in radians. Radius of this wheel is known, and that is 20 centimeter. Now question is, what is this angle? 3 quarters. 1 quarter is pi by 2 radians. So 3/4 is what? 3 pi by 2 radians. So length of arc or the distance traveled by the cycle would be radius, that is 20 centimeter into theta, this angle. Angle is 3 pi by 2 radians. So 3 pi by 2, answer would be in centimeters. This is 10, so answer is 30 pi centimeter. So the distance traveled by the cycle or the length of this arc is 30 pi centimeter. So now here we are to discuss some of the problems based on area of sector. So we have just seen a formula. Area of a sector is given by formula half r square theta, where theta is measured in radians. Based on that, let's solve two problems. I've written two problems here. The first one says, find area of a sector of circle of radius 5 meter and central angle 40 degree. I'll draw a supporting figure here. There's a circle, radius of which is 5 meter, in which there is a sector, central angle of which is 40 degree and radius is 5 meter. What you have to do is, you have to measure this area. So what you have to do is, you have to measure the area of the sector of a circle of radius 5 meter, central angle of which is 40 degree. So how do you use our formula? Area of sector we have just stated is what? Half r square theta in radians. So area of sector is half r square theta, where theta is measured in radians. So let's put the values. Half, radius here is 5 square, theta here is what? 40 degrees, but we want measure of this angle in radians. So 40 degrees into pi by 180, this is in radians. So this gets cancelled, this is cancelled, and this is 9. So 5 square is 25, 25 by 9 pi centimeter, sorry, meter, unit this time is meter. So meter square. So answer is 25 pi by 9 meter square. Let's see how we got this result. Area of sector is given by formula half r square theta. R is radius, theta is measure of the central angle in radians. So half, radius is 5 square, theta is 40 degrees, but we want theta in radians. So multiply it with pi by 180. 0 gets cancelled, cancel it by 2. This is 2, cancel it by this. Answer is 9. 5 square is 25, 25 pi by 9 meter square. So that's your area of the sector of circle of radius 5 meter and central angle 40 degree. Now, moving to next. I've written one more question here. Question is, area swept by second hand of a clock of length 6 centimeter in 10 seconds. So there is a watch, second hand of a clock, second hand of which is of length 6 centimeter. It traces some area in 10 seconds. Question is, what area is swept by that? So I'll draw a supporting figure here. Suppose this is second hand of a clock. In 10 seconds, it rotates by some angle, and this is the area swept by the second hand of a clock in 10 seconds. Radius of this sector is 6 centimeter, that is length of second hand of a clock, and angle swept, which is not known till now, suppose is theta in radians. Right? So let's go back. Area of sector is what? Half r square theta in radians. Radius here is what? Length of the second hand of a clock, which is mentioned, that is 6 centimeter. So radius is known. Half r square. R is 6 square. Now the big question is, what is theta? What is theta in radians? So first of all, I don't know degree measure of it. Then what to do? Again, we'll use unitary methods. In what time does second hand of a clock completes one rotation? In what time does the second hand of a clock completes one rotation? So it takes 60 seconds to complete one rotation. and one rotation is what angle? 2 pi radians. So I'll say 2 pi radians in 60 seconds. So in 10 seconds it will be 2 pi by 60 into 10. Right? So answer is this gets cancelled, this gets cancelled, this gets cancelled. Answer is 6 pi centimeter square. That's the area of the sector. So area of the sector, or area swept by second end of a clock of length 6 centimeter in 10 seconds is 6 pi centimeter square. Okay.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment, and make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
So now after solving few problems on area of sector and length of arc, let's move to the next topic, that is perimeter of a sector or circumference of a sector. Perimeter of a sector. If you see here in the figure, a sector OAB is drawn. Here, a sector OAB is drawn. Now, perimeter means what? Length of the boundary. So, boundary of this sector has three parts. One is OA, the length OA, then is AB, arc AB, and then OB, right? So, perimeter of the sector or the circumference of sector is, in this case, is OA plus AB plus OB, right? OA and OB are what? Radii, and AB is what? Arc. Okay, so OA and OB are radii and AB is arc. Now, if this angle AOB measures theta radians, if angle AOB measures theta radians, then length of arc AB is R into theta, right? length of r is r into theta. So perimeter of the sector OAB, perimeter of the sector OAB is OA plus length of arc AB plus OB, r plus r theta plus r. So perimeter of sector is 2r plus r theta. Take r common, r into 2 plus theta. So this is the expression or formula for perimeter of a sector. Remember once again, here theta is measured in radians. It's not degree measure of the angle, it's radian measure of the angle, right? So we'll move with this formula. Perimeter of the sector is r into 2 plus theta. Now let's solve one or two numericals again, problems again, to understand it in better way. So let's solve some problems based on perimeter of sector. Here I've written two questions. The first one, find perimeter of sector of radius 15 cm and central angle 75 degree. It's an easy sum, direct substitution based. So I'll draw a supporting figure here. There is a sector of radius 15 cm and central angle is 75 degrees. What we need to do is we have to find perimeter of this sector. So what we have to find is perimeter of the sector. As we have seen in explanation part, perimeter of sector is r into 2 plus theta radius. 2r, that is radius plus radius, and r theta, that is length of this arc. So that gives us perimeter of the sector. So if I go by formula, perimeter of the sector is r into 2 plus theta. This 2r stands for twice the radius and r theta is the length of the arc. So radius is given. Radius is 15 centimeter. 2 is a number. Theta is the angle in radians. So here it is 75 degrees. So 75 degrees. We have to substitute the value of theta in radians. So multiply by pi by 180. Cancel by 15. This is 5. This is 12. So 5 pi by 12. The answer is 15 to the 30 plus 15. Cancel by 15 into 5. 75 by 12. Cancel by 3. 25 by 4 pi. That's your answer in centimeters. If you further want to find its final value, you can put pi is equal to 3.14 into 25 would be somewhere 82 upon 4. So whatever it comes, you substitute pi equals to 3.414 and calculate it. Okay. Now moving to next question. This is an indirect question. Here, perimeter of sector is what we have to find of radius 12 centimeter, area of which is 12 pi centimeter square. So there is a sector, radius of which is 12 centimeter, and this time central angle is not mentioned. This area is given. Area is 12 pi centimeter square. So if angle was given, I would have directly substituted the values in the formula. Perimeter of the sector is r into 2 plus theta. But this time angle is not given. So what we'll do is, first we'll find measure of the central angle. By using the data that area of the sector is 12 pi centimeter square. So if you remember, area of sector is given by formula half r square theta, that is 12 pi in this case. So theta in radians is 12 pi into 2 by r square. Radius is 12, so 12 square. So 12 square, that is 12 into 12. Cancel, this is 6. So theta in radians is pi by 6. Right. So we have to find perimeter of the sector, radius of which is 12 centimeter, and now central angle, which was not known, is known now, and that is pi by 6. So perimeter of the sector is what? R into 2 plus theta in radians. Radius is once again 12. So this is 12 2 plus theta. Theta is 5 by 6. This answer would be in centimeters as radius was in centimeter. Open this bracket, 12 to the 24 plus 12 into pi by 6, that is 2 pi centimeter. If you assume pi to be 3.14, then twice of it is 6.28, and the final answer would be 30.28 centimeter. So this is perimeter of the sector, radius of which is 12 centimeter, and area of the sector is 12 pi centimeter square. Right? Now, moving to our last topic, that is area of the segment. Let's see how to measure area of a segment. Consider a sector OAB. Here OA and OB are radii, let us say is R, and the angle OAB here is theta in radians. Join A and B, this AB is called. So segment here is the portion of the sector outside triangle OAB. Segment here stands for what? The portion of the sector that is outside the triangle OAB. So question is how to measure that area. So by area addition property, we can say area of segment area of the segment AB will be equal to area of sector OAB minus area of triangle OAB. Area of the segment will be area of the sector OAB minus area of triangle OAB. So area of sector OAB we know very well is how much? Half r square theta, where theta is measured in radians. Right? Area of sector OAB is half r square theta, where theta is measured in radians. Now, let's measure what is area of the triangle OAB. So now consider triangle OAB. Let's measure area of triangle OAB. So we know area of triangle is measured as half base into height. So if I consider OA as the base, then question is what is height of the triangle? So draw a perpendicular from A, B on OA to meet OA at some point C. So if OA is the base of the triangle, then BC is height of the triangle. If I say OA is base of the triangle, then BC is height of the triangle. Now let's measure BC. BC first. So to measure BC, we'll have to use little of trigonometry. In the triangle OBC, what will be value of the trigonometric ratio sine theta? So sine theta, which is defined as opposite side, ratio of opposite side and hypotenuse. So sine theta in this triangle is BC by OB. OB is hypotenuse and BC is opposite side. So BC by OB. Let's rearrange the term. So BC is what? OB into sine theta. And OB is what? Radii. So R sine theta. So height of the triangle OAB corresponding to the base OA is R sine theta. So area of triangle OAB, now once again, is half base into height. So half OA into BC. Half OA into BC. OA is measured as radius. So half R into BC is R sine theta. So half R into R sine theta. That is half R square sine theta. So area of triangle OAB is half R square sine theta. So coming back to area of segment. So area of segment, which I mentioned earlier, is area of sector minus area of triangle. So area of sector is what? Half R square theta, and area of triangle is half R square sine theta. Therefore, area of segment is half R square theta minus half R square sine theta. Half R square if you take common, so we have half R square into theta minus sine theta. Right? So area of segment is half R square theta minus sine theta. And let me remind you, theta here is measured in radians. Right? So that's all in concepts. Now I'll take you to problem solving. We will solve few problems based on area of segment, so as to clear the concept. right? So let us solve a problem based on area of segment. I've written a question here. In a circle of radius 18 centimeter, an arc subtends 30 degree at the center. Find area between chord and arc. I'll draw a supporting figure here. There's a circle in which there's an arc, measure of which is 30 degree, radius is 18 centimeter. What you have to do is, you have to find the area between the chord and the arc. You have to measure area between the chord and the arc, that is this one, which is actually segment of the circle. So what we have to do is, we have to measure the area of the segment of the circle of radius 18 centimeter and angular measure 30 degree. So area of segment, let's name this figure as OAB. So area of segment is what? Half r square theta in radians minus sine theta. We have seen this formula just now. So area of segment is what? Half r square theta in radians minus sine theta, right? So answer would be half. Radius in the figure is 18. Radius in the figure is 18. So 18 square, that's 18 into 18 into theta. Theta is 30 degrees. We have to convert it into radians. So 30 degrees is 30 into pi by 180 radians minus sine theta. Here I can write in degrees as well as in radians. One and same thing. So this is what, if I consider the half, 9 into 18. This is pi by 6 minus sine 30 degree. Sine of 30 degree is half. Sine of angle 30 is half. So answer would be, if I multiply it inside, this gets cancelled by 6 to 3, 27 pi. Answer would be 27 pi minus 9 into 18, 162 by 2 is 81. So minus 81. Answer is in centimeter square. So area of this segment is 27 pi minus 81 centimeters. If you can take 27 common, the answer will be 27 into pi minus 3 centimeter square. So that's area of the segment. This one, area between the chord AB and arc AB. That's area of segment, and its value is 27 into pi minus 3 centimeter square in this example, right? So this is how we calculate area of segment, and this is end of the chapter. Okay.